Hi, chemistry class. Mr. Worley here, section 7-4. Let's look at our objectives. Define empirical formula and explain how the term applies to ionic and molecular compounds. Determine an empirical formula from either a percentage or mass composition. Explain the relationship between the empirical formula and the molecular formula of a given compound. And determine a molecular formula from an empirical formula. Okay, we also have page 249, numbers 1 through 5, as well as, I'm just going to say 2, hold on, I need to write this down. We need to do sample problems L and sample problems M. I'll let you say L or M. You choose which one you want. Okay. Well, make sure you have a textbook. Make sure that you have a piece of paper to write on, and 2 colors, one for sample problems and one for note-taking. And let's begin. Determining chemical formulas. Let's read together. Up, up, up. When a new substance is synthesized or discovered, it is analyzed quantitatively. Remember, quantitatively means with numbers and measurements. Quantitatively, to reveal its percentage composition. From these data, the empirical formula is then determined. An empirical formula consists of the symbols for the elements combined in a compound with subscripts showing the smallest whole number mole ratio of the different atoms in the compound. For an ionic compound, and this is a vocabulary word, before you write it all down, let's finish this paragraph so that you can kind of get a better idea of what this means, because it's a long definition. For an ionic compound, the formula unit is usually the compound's empirical formula. For a molecular compound, however, the empirical formula does not necessarily indicate the actual numbers of atoms present in each molecule. For example, the empirical formula of the gas diborane is BH3, but the molecular formula is B2H6. So what they're saying is in the molecule actually has 2 borons and 6 hydrogens. But its empirical formula, simplest ratio of atoms, there's 1 boron to every 3 hydrogens. In this case, the number of atoms given by the molecular formula, corresponds to the empirical ratio multiplied by 2. So they're saying this is 2 times this. So, what is an empirical formula? Well, now you can write the definition, and you can see that the empirical formula is the simplest ratio of atoms in a molecule. It doesn't necessarily represent the molecule, simplest ratio. In your notes, you might write something like this. And then here you'll write the definition, and then give yourself an example. Write down diborane, for example. Empirical, and the actual molecular formula here. Okay, here's another example you might want to write down. The empirical formula for hydrogen peroxide would be HO, but the molecular formula would be H2O2. All right, so you can see that the empirical formula is different than the molecular formula. Let's keep reading. Calculation of empirical formulas. To determine a compound's empirical formula from its percentage composition, remember percentage composition is what percent by mass does each element represent in a formula, being by converting the percentage composition to mass composition. Let's read that again. To determine the compound's empirical formula from its percentage composition, begin by converting percentage composition to a mass composition. Assume that you have 100 grams of sample of the compound. Then calculate, oh, Sorry about that. Then, calculate the amount of each element in the sample. For example, the percentage composition of diborane is 78.1% boron and 21.9% hydrogen. Therefore, 100 grams of diborane contains 78.1 grams of boron and 21.9 grams of hydrogen. Okay, so what I'm underlining right here, this is called the percent composition. You might want to write this down. Why? Because we're using a lot of words that sound the same. Kind of. And what is this? With the gram, you can see why? Because it's got percentage signs. Here, what I'm underlying next is what? Mass composition. You might want to write that down in your notes. It looks like a pretty good quiz question. Now, next, the mass composition of each element is converted to a composition in moles by dividing by the appropriate molar mass. So, if you have 78.81 grams of boron, divide by the molar mass of boron, which is 10.81, periodic table, if you don't know, and you'll get 7.22 moles of boron. Okay, and for 21.9 grams of hydrogen, you get 21.7 moles of hydrogen. All right, let's keep reading. These values give a mole ratio, and this is the important part, mole ratio of 7.22 moles boron and 21.7 moles hydrogen. However, this is not the ratio of smallest whole numbers. To find such a ratio, and that's the empirical formula, to find such a ratio, divide each number of moles by the smallest number in the existing ratio. The existing ratio is the numbers you already have. For example, 7.22 moles of boron, that comes from here, and 21.7 moles of hydrogen, that comes from here. You're going to divide these by the smallest number. Well, what is the smallest number between these two? 7.22, and that's exactly what they did. So, they get 1 mole of boron for every 3.01 moles of hydrogen. All right, please go to the next video and turn the page.